Okay, let's continue to work on this familiar and convenient form of equations to us up to this point. Why is it convenient? Because we can find a lot of these things that are important features of the graph very easily. The most important and convenient one, though, is the vertex. Don't forget that that's the most important one. Get familiar with that. X and Y intercepts is something that we just started to do in the previous video. Point of symmetry we haven't done yet is the focus of this practice. So I'm going to put that this is a new term or definition, but rather than giving you a definition now, I like to show you in our practice. Equation of the line of symmetry, something we've been doing for quite a while now. And at the end, we're going to put it all together and make a nice smooth graph of a parabola as best as we can. All right, so the skills required for this practice are to be able to sketch equations in this form, solve quadratic equations very quickly and comfortably, and pretty much everything that's been covered in the last 6 videos, all right? So if you're struggling, don't forget to refer back, because at this point, I'm going to speed up and show fewer steps algebraically. I'm trying to focus on the concept for this lesson. All right, so let's get started. I would like to first label the coordinates of the vertex. That's the easiest thing to identify. So 1a, the coordinates of the vertex, like we said, it's a very convenient form, are 3, negative 16. So hopefully you're comfortable with that. 3, negative 16. Don't forget the line of symmetry passes through there also. So matter of fact, I'll write that next. Letter D. It doesn't have to be in the order that is shown in the left side. We know the line of symmetry is x equals 3. What can we find next? Our x and y intercepts. So let's do that here. On the right side, I'm going to write letter B. And then what do we know about all the x intercepts? That's a new idea from last time. It is that their y value is 0. Hopefully you thought of that before I wrote it down. And then what we can do is, for this problem, I'm going to show all the work, but I'm going to show fewer steps as we go along. So all we're going to do is take this y value and substitute it with a 0. So we will write 0 is equal to something squared minus 16. That something is x minus 3. And we can undo the subtracting 16 by adding it to both sides. We will add it to both sides. And on the left side, we get 16 equals something squared. The something is still a x minus 3 term. And then we know 2 possible numbers were squared for a 16. Those were a positive and negative 4. That is equal to the something x minus 3. And lastly, we can write, so see, I'm trying to skip all these steps. I did that a while back and during solving equations, and I showed it in the last video. So positive 3 plus or minus 4. And hopefully you're making a connection. We said the line of symmetry passes through the line x equals 3. Notice how x starts at 3, and then we add and subtract 4. So we can see that those 2 numbers will be, or those 2 intercepts, I'll label them as points. Don't forget their y value is 0 for both of them. And let's do them individually. 4 plus 3 is 7. So 7 comma 0 is an x intercept. And 3 minus 4 is negative 1. All right, so far we have x intercepts. And lastly, we need y intercepts. So I'll probably do that over here. Y intercept. What do we know about all the y intercepts? Is that their x value is 0. Great. So let's substitute that into the original equation. This x will be replaced with a 0. And again, I want to show fewer steps each time. So I'll show all the steps right now. 0 minus 3 squared. So that way you think about what I'm doing in the next few problems when I show fewer. And that just becomes negative 3 like this, negative 3 squared. So again, I'm going to stop showing that every time. So therefore we get 9 minus 16, which is negative 7. All right, and that simply becomes the point 0. Don't forget the x value was 0, negative 7. So look at that. We have 2 points right there. We have one more point representing a y-intercept. We had the vertex. I think we have enough to make a pretty nice sketch, and we have the line of symmetry. Again, you can do this in any order that you would like. In the previous video, I sketched all of this first, and then now I'm switching it up, as you can see. It doesn't matter the order, as long as your work is correct and your thinking is the correct thinking. All right, vertex of 3, negative 16. I'm going to assume it's somewhere right there, right? 3 is not drawn to perfect scale, but we're making a pretty accurate sketch. And then we know that the idea I wanted to point out is that this means 3 plus 4 and 3 minus 4. Remember that it means 3 plus 4, and it also means 3 minus 4. So I'll show you in the picture one time. And it means that x equals 3 is the line of symmetry. That means that this 3 hopefully you see this 3 is the same as this 3. It's saying to find the x-intercept, start at x equals 3 and then go 4 units to the right. So if this is 3 right here, if this is 3 right here, we need to go 4 units to the right to get to x equals 7. So somewhere right there, we get to 7, 0. And now the other one states 3 minus 4. 3 minus 4, that means start at 3, x equals 3, and go 4 units to the left. So somewhere right there. And hopefully you can see, I'm going to use a different color. Hopefully you can see this was a distance of 4 units to the right. This, remember, this was x equals 3. And this is 4 units to the left. The negative represents the direction to the left, and the positive represents the direction to the right. There it is. This is the algebra. This is the picture for this. This is algebra. This is the algebra. This is the picture for that. So hopefully you can visualize that nice parabola. As a matter of fact, I'm going to connect all those points right now. Use that opportunity to put all the pieces of the puzzle that we've found so far together. And remember that I'm doing this one pretty slow right now, but we're going to expedite this process in the next few examples, hopefully. All right, there it is. Look at that. Oh, I forgot to label 1. This looks really like a really nice graph. This was -1, 0. Is there a point that we haven't labeled? That's right. It is the y-intercept, which we solved for right here. This is 0, -7. All right, so far we found everything except X and Y intercepts we checked, vertex we checked, equation of the line of symmetry check, graph check. The only thing we're missing is this, point of symmetry. So I want to highlight that now, and I'll use a different color. Matter of fact, I've already shown you two points of symmetry to each other. This point right here is a point of symmetry to this x-intercept. It's a point of symmetry to the other x-intercept. Why? Because the distance is 4 from each side of the line of symmetry. So the vertex doesn't have, look, notice how the vertex doesn't have one that's missing a match. That's fine. But this point is missing a point of symmetry. So what we need to figure out, and I'll use a different color to avoid confusion. What we need to figure out is what is this distance from here to the line of symmetry. And look, that's very simple. The x value here is 0. The x value here is 3. So therefore, this must be a distance of 3. And what must this distance be then? It has to also be 3. Therefore, what we can label now is this new point of symmetry, which, matter of fact, I'm going to underline it in blue to give you a definition of that. That point of symmetry is, for example, 4 on each side of the line of symmetry, 3 on each side of the line of symmetry. And the only one that we were missing was the corresponding one to the y-intercept. So that means that the x value changed by 2 times, giving us a x value of 6. But the thing that you should notice is the y value doesn't change here. If this is -7, what should this y value be? -7. And hopefully you can say that. For a point of symmetry, the y value here is 0, and the y value here is 0. Those points don't change. And what I mentioned is, because the vertex is right on the line of symmetry, it doesn't have a different matching point. It's itself, all right? You can think about it that way. But look, we label a total of 1, 2, 3, 4, and 5 points. That's our goal for every one of these graphs today. And my goal is to show fewer steps each time so that hopefully you use your brain a little bit more and a piece of paper if you need to. Okay, so here we go. That was really fun. Let's do another one. I really had fun doing that. Cool, but we're gonna have more fun because we're gonna expedite the process. If you want to try any of these ahead of me, you're more than welcome to pause and press play to check whenever you're ready. All right, one thing I want to point out is that we have rarely seen this format in a while, but I do want to point out that this is the same as y equals. I like to see the positive in front first, so I would write it as 25 minus something squared. Remember that the negative belongs to the negative, or it belongs to the something squared. The negative symbol belongs to the something squared. So as long as I associate the correct symbols with each other, is the same statement. So these are the same. Just use whatever format you're more used to. So I like to think of this format, but it doesn't matter. I'm comfortable graphing in this form. The order is just reversed. All right, so here we go. I'm going to start with, and again, maybe I don't even look at the order that I did the last time. I'll probably start doing something different. I don't know. So for 2, the vertex is located at, whichever form you use, is going to be -4, 25. -4, 25, comma 25. And that means that the line of symmetry is at x equals -4. As a matter of fact, I think I'm going to start showing that on my sketch some point. So let's say that x equals, what was it, -4? Let's say that x equals -4. That's not a straight line. Let's say that x equals -4 is right there. I know the vertex is somewhere here at the y value of 25. And I'm going to stop right there and not make a parabola yet until I know more about the x-intercepts and y-intercepts. So let's show some more of that work here. X-intercepts, what do we know about all the x-intercepts? That their y value is 0. And again, like I said before, I'm going to skip some steps now. I'm going to immediately replace this 0 with, I like this equation above better. So let's say that 0 equals 25 minus something squared. And I know that 25 is going to equal, whoops, let's redo that. The something is x plus 4. And because we have negative something squared and a 0, we're going to add that to both sides. That's my favorite move. Something squared equals 25. And the something is x plus 4. So therefore, x is a -4 plus or minus, positive or -5. I wanted to speed that up a little bit, so hopefully you can see how I got that solution, all right? And if you need to take more time, work it out yourself. And that tells me the two x-intercepts, one of them is -9, comma 0, and the other one is -4 plus 5 is 1, comma 0. So there we go. Make sure that you plot those fairly, you want to think of that symmetry, you know, fairly symmetrical to each other. If this is a distance of 5, then this better be a distance of 5. That's how you want to think about that. And that looks about right to me. And I started to see some nice connect dot kind of figures here, which are we were very familiar with, called parabola. Something like that. Not my best one, but notice how it crosses the y-axis there, which we still need to figure out. We already figured out these 2 points. This one better be the -9, comma 0. And remember, keep in mind that distance of 5 to the right and 5 to the left. Visualize that. And lastly, we will show it here on the left. On the left side, y-intercept. What is known about all the y-intercepts? X is 0. So therefore, we will get y equals, let me show you the equation so you know what I'm working with. Y equals -4 squared plus 25, which becomes, really be careful, this is -16 since the negative is on the outside of the parentheses. So -16 plus 25, that's a 9. So 0, 9 is what should be labeled here. Check your own work. And we have, at this point, 1, 2, 3, 4 points. We're missing one point that we just gave a definition to. It is that point of symmetry. What's the distance from here to the line of symmetry? That's the key right here, because the x value is here is 0. So that distance is 4. Therefore, what should be this distance from the graph to the line of symmetry? It should also be 4. If we have 4 2 times in the negative direction, that new point of symmetry is not an 8 now, it's a -8. And the nice thing is that the y value does not change. So -8, 9. There are our 5 points labeled. Great. Let's see if we can speed up. That's always our goal. If you're feeling like speeding up is not something that's required for you right now, then take your time. No worries. But I'm just trying to keep the video shorter for you. All right, so let's do this again. Vertex is 2, 49. Hopefully you're okay with that. That means the line of symmetry, I'm going to use my green color. Line of symmetry is at x equals 2. X equals 2, and this is letter D. Next thing that we know is the vertex. Oh, I haven't labeled it, but we need to solve for x and y intercepts. Another thing we should already be thinking, I see negative something squared, so I know this is going to curve downwards. And let's figure out what the x intercepts are going to be. X intercept is when, look, hopefully you can see that I'm going to go straight to 49. Skip that work. Like I said, 49 equals something squared. Hopefully you can see how I did that, since what was allowing me to do that, that the y value was equal to 0. So hopefully you can feel confident doing that yourself for your future practice. And therefore we can say that x is equal to a positive 2 plus or minus 7. And again, if you need to show the additional steps here, that's fine, all right? I'm just trying to show you the concept. I've shown you this many times before. So therefore we can write the x-intercepts as 7 plus 2 is 9, 9 comma 0. And the other one is 2 minus 7, my fault, 2 minus 7 is negative 5, comma 0. Labeling those should, hopefully you notice that all of what we get here should make sense in this picture. If something doesn't fit, then you go back and check your work. So I'm going to check that now. So this is saying start at 2 and go 7 to the right. Starting at 2 and going 7 to the right takes us to about, takes us to 9. All right, so this is a distance of 7. This is a distance of 7. That's 9 comma 0 then. And now we have to visualize this same distance on the left side. That same distance of 7 is going to be somewhere here, I think. That looks about right. And let's label that negative 5 comma 0. And notice how we can connect those, put those pieces of the puzzle together very nicely and smooth at this point. Something like that. Oh, that was not very good. Let me try that again. Even though it's not the most accurate sketch, I do want to visualize that curvature and symmetry, make it as accurate as possible. And right now I'm having a hard time, but hopefully you're having a better time than I am. This is my last attempt. There we go. That's a lot better. And that was the hardest part usually, you know, but that's why it's easier to sketch them rather than focus on perfect accuracy. All right, and the last thing I noticed haven't labeled yet is the y-intercept. That is when x equals 0. So remember to use this original equation, plug in a 0 right there, and then we should get y equals 49 minus negative 2 squared, which really becomes 49 minus 4, or 45. 45, sorry. It should be written as a point. 0, 45. So I'm going to label that right here, 0, 45. And one last point is missing. We call that our new definition, point of symmetry. So notice that the distance should be 2, clearly stated by the line of symmetry. If this distance is 2, that distance is 2. Therefore, this point is 4, comma 45. And don't forget that, it looks a little confusing now. Don't forget that the vertex is this one. All right. There it is. That's 5 points clearly labeled. We have 2 more to go. Let's see if we can do this quickly. Again, if you need to pause or rewind, do that right now. Let's do it. So I want to start with vertex. Usually that's why it's the most convenient form. It's going to be negative 4, comma 100. So start with that. Negative 4. And I notice already it's going to be negative something squared. We've done a few examples of these. I guess those are my favorite. Negative 4, comma 100. And then we were going to find x and y intercepts. X intercepts, that's right, y equals 0. So therefore I can say, we can immediately go to 10 or 100 equals something squared. The something is x plus 4. And I like to write x equals a negative 4. You check your own work at your own pace, plus or minus 10. Therefore, I know the intercepts are negative 14 and 0. We got negative 14 by negative 4 plus 10, minus 10. And now we got to do negative 4 plus 10, which is 6. And again, what this means right here in the picture is it states start at negative 4 and then go 10 units to the right, you should arrive at 6. And then it's stating that if we start at -4, but then go the same number of units to the left, then we arrive at -14. All right, and at this point, the hardest part for me is to make that smooth curve. So let's see how it goes this time. I'm pretty pleased with that, except this part right here. Let's smoothing it out like that. There we go. And then finish the sketch. Oh, I like that one. There we go. And lastly, we are yet to label this point. Let's show the work here on the left side. What do you know about the y-intercept? Is that their x value is 0. And therefore, we know that we are going to get y equals 100 minus 4 squared, or y equals 100 minus 16, which is 0, 84. I'll challenge you right now. See if you can label the point of symmetry before I do right now. And I'm gonna use color. So, but at some point you don't have to draw this anymore. Hopefully you can visualize what's this distance right here? I'll give you more time so that you can think about it before I do. It is 4. And what's this distance right here? It is 4. Therefore, it must be a -8, 84. I hope that you got that one before I did. And if not, it's okay as long as you get the correct answer. But I like this. We're able to label 5 points on almost on any parabola of this format. That's pretty cool and very efficiently. We're doing it pretty quick. This is going to be our last example, I'm pretty sure. That's going to require some time. And this is one of the ones that I don't want you to miss on because while they're not commonly used, you still can graph them if you wanted to, because you'll see why. All right, so vertex. What do you know about the vertex? You tell me before I write it. It's -2. -17. That's right. That means the line of symmetry at -2. Line of symmetry at -2. What's the y value there? We said it was negative. So I'll just label that -2, -17. Then we're going to solve for the x-intercepts. X-intercepts, we know that y value is 0. So we're going to say, maybe I'll show more work for this one. But I'll start with here. 17 equals something squared. Something is x plus 2. The idea for this one is the 17 is not a perfect square integer like all the other ones were perfectly and carefully chosen. But we know we can still square two numbers to get that. What are they? Plus or minus the square root of 17. And that is equal to the something, x plus 2. So now we can say x equals 2 plus or minus the square root of 17. One thing to keep in mind is that the square root of 17 is a little bit more than 4. So maybe I'll write it like this. A bit more than 4, just a little bit more than 4. So you can pretty much say 4 and a little bit more. All right, think about it like that. Square root of 17 is just a number just slightly bigger than 4. That will help us with our thinking. All right, so if it's saying start at 2, if it's saying start at 2 and go 17, square root of 17 to the right, think about it as start at 2 and go a little bit more than 4 to the right. So a little bit more than 4 to the right should be somewhere right here. Because if this is 2 units, then a little bit more than that should do it. And whatever this distance is, square root of 17, do the same to the other side. Somewhere right there. You already know we were getting comfortable with this, and now put the pieces of the puzzle together very nicely in this sketch, as we've done before. Look at that. That's not too bad. Although maybe I should redo it. But you try and label those points before I do, as I'm struggling with my curvature. I'm just gonna do it like that. There we go. That's good enough for me. All right. So the one thing that you gotta remember, the x coordinate is 2 plus square root of 17. but the y value is 0. So if we start at 2 and we go square root of 17 to the right, the only way we can label this one right here is 2 plus the square root of 17 without using a calculator, comma, 0. The y value is 0. The x value is 2 plus the square root of 17. We just represent it. And we can do the same thing here on the left side. Because we started at 2 and then went square root of 17 units to the left, we're going to label this x coordinate 2 minus the square root of 17. That's the way we can label that. And the nice thing is that we could actually solve for this one. That one's not too bad. So we're going to say y-intercept is when x equals 0. So therefore, y equals 2 squared minus 17, which is 4 minus 17. 4 minus 17 is negative 13. All right, so we label 1, 2, 3, 4. We're missing that point of symmetry. Let's do it in blue as we got accustomed to just in this practice. You don't have to use color or even label anymore. As long as you're thinking 2 and 2, on the negative direction makes a negative 4, comma, what value remains the same? The y value, negative 4, comma, negative 13. And there it is, the most advanced that you can think of. If you can feel comfortable working with these 5 problems, you're ready for any of the ones that come at your way. All right, so this is the end of our practice. Stay tuned and see you on the next one.